Rule-based AI. In 1972, a computer at Stanford diagnosed blood infections better than most human doctors and never treated a single patient. MYCIN got it right 69% of the time. Doctors, 65%. Stanford built an expert system with 600 hand-coded rules. If blood culture shows gram-negative rods and patient is immunocompromised, then recommend gentamicin. Every possible scenario, manually programmed by humans who spent years translating medical knowledge into logic trees. It worked. Hospitals refused to use it. Too weird. Too black-boxy. Never mind that it was literally better than doctors. Nobody trusted a computer to make life or death decisions. MYCIN died in a lab. Perfect and unused. Here's the uncomfortable part. We were already worried about trusting AI in 1972, and we built it anyway. These systems were everywhere. Dendril identified molecular structures. XCon configured computer systems for Digital Equipment Corporation and saved them $25 million annually. All of them required armies of knowledge engineers, extracting expertise from human specialists and converting it into if-then statements. Thousands of rules, tens of thousands. The bigger the system, the more brittle it became. One wrong rule and the whole thing collapsed. Maintaining these systems was a nightmare. Add a new rule, break 3 old ones. It was like building a house of cards in a wind tunnel. But here's what nobody saw coming. We were teaching computers to make decisions we didn't understand. Even with hand-coded rules, people couldn't track how MYCIN reached conclusions. The explanation feature showed the logic chain, but doctors couldn't follow it. Too many variables. Too complex. Machine learning. Then in the 1990s, someone had a terrible idea. What if we stopped telling computers the rules and let them figure it out themselves? Spam filters learned what spam looked like by reading millions of emails. No if-then statements. Just patterns emerging from data. Neural networks started, recognizing handwritten digits without anyone programming the rules for what makes a 7 look like a 7. We stopped understanding how decisions were made. The black box problem wasn't a bug. It became the entire system. And if you think losing control of simple spam filters is concerning, wait until you see what happened when we scaled this up. Deep learning. September 30th, 2012. A PhD student in Toronto submitted results to ImageNet that made every computer vision researcher look like they'd been working with stone tools. Alex Krzyzewski's neural network achieved 15.3% error rate. Second place, 26.2%. He won by nearly 11 percentage points using 2 NVIDIA GTX 580 GPUs in his bedroom. Not a corporate lab, a bedroom. The secret wasn't genius. It was brute force and audacity. Multiple layers of artificial neurons, each learning increasingly abstract features. First layer learned edges. Second layer learned the textures. Third layer learned object parts. Top layers learned entire concepts, all automatically. No human told it what a cat looked like. It figured it out from millions of images. Google bought the team immediately. Microsoft panic pivoted their entire research division to deep learning. Facebook rebuilt their infrastructure around neural networks. Every company that ignored AlexNet became irrelevant within 3 years. The AI revolution started because someone had enough GPU power and refused to believe everyone who said neural networks were outdated. Here's where it gets weird. Nobody fully understood why deep learning worked so well. We still don't. We just know that stacking layers and adding data makes it better. It's like discovering fire without understanding combustion. Reinforcement learning. By 2016, AI stopped needing human examples entirely. DeepMind's agents played Atari games millions of times, learning through trial and error at superhuman speed. No human gameplay required, just a reward signal. Maximize score. The AI figured out strategies humans never discovered in decades of playing. Then came AlphaGo Zero. Learned Go from scratch in 3 days. No human game, just the rules and self-play. It crushed the version of AlphaGo trained on human expertise 100 games to 0. Every strategy humans developed over 2,500 years of Go history, irrelevant. The machine taught itself better. AI stopped needing human knowledge. It could generate its own, but it still needed humans to define the goal, to set the reward function. That dependency is about to evaporate, and when it does, things get properly dangerous. Natural language processing. In June 2017, 8 Google researchers published a paper titled "Attention is All You Need," and accidentally created the architecture that would power every major AI system for the next decade. They were trying to improve translation. They built transformers, neural networks that could understand context by paying attention to relationships between all words simultaneously, not just adjacent ones. The word bank means different things in riverbank versus bank account. Transformers understood this. Previous models didn't. Google deployed BERT in 2018, and search results got noticeably smarter. Microsoft licensed it immediately. The entire NLP field restructured around attention mechanisms within 18 months. Here's the terrifying part. Those researchers didn't know they'd invented the foundation for GPT, Claude, and everything you're using now. They were solving a translation problem. The transformer architecture's full potential was an accident discovered after publication. We stumbled into the most important AI breakthrough in a decade, and nobody understood why attention mechanisms worked so well. We still don't have a complete mathematical explanation. We just know, add attention, performance improves. It's a recipe without understanding the chemistry. Large language models. May 2020. OpenAI trained GPT-3 on 175 billion parameters and 45 terabytes of text. It could write news articles, answer questions, generate code, and compose poetry. The problem? It was phenomenal at generating convincing misinformation. Prompt it with, write a fake news article about vaccines, and it produced something that could go viral in minutes. OpenAI kept it behind an API waitlist for months. People called it AGI, which was hilarious because GPT-3 couldn't reason, fact-check itself, or understand what it was saying. Sophisticated, autocomplete, not intelligence. But it proved language models could be genuinely useful. Then researchers discovered something nobody predicted. Make the model bigger, it gets smarter. No architectural changes needed, just scale. GPT-3 had emergent abilities GPT-2 didn't have. Abilities that appeared suddenly at certain sizes. We don't know why this happens. We just keep making them bigger and watching new capabilities emerge like magic. Language models could read and write. Then someone taught them to see. Multimodal AI. January 2021. OpenAI released Clip, a model that understood images and text together. Feed it a picture and it could describe it. Feed it a description and it could find matching images. Researchers immediately weaponized it to generate images from text prompts. Type astronaut riding a horse and watch it hallucinate into existence. DALL-E launched April 2021. Midjourney followed July 2022. Then, Stable Diffusion went open source in August 2022 and chaos erupted. No waitlists, no filters. Anyone could generate anything. The model trained on 5 billion image-text pairs scraped from the internet, including millions of copyrighted artworks, stock photos, and personal images, all without permission or compensation. Artists watched their distinctive styles become purchasable prompts. Greg Rakowski, a digital artist, discovered his name appeared in 93,000 Stable Diffusion prompts. His style, developed over decades, now reproducible by anyone who could type 6 words. Getty Images sued Stability AI in February 2023 for scraping 12 million copyrighted photos. Art communities banned AI-generated submissions. Adobe integrated it into Photoshop. September 2022. Jason Allen won first place at the Colorado State Fair art competition with Teatro d'Opera Spatiale, created using Midjourney. He was transparent about the AI usage. Artists were furious anyway. The discourse exploded. Is it theft? Is it art? Does it matter if the result is indistinguishable? We didn't resolve any of these questions. We just normalized it. Generative AI mainstream. November 30th, 2022. OpenAI released ChatGPT to the public. Within 5 days, 1 million users. 2 months, 100 million users. TikTok took 9 months to hit that milestone. Instagram took 2.5 years. The difference wasn't capability. GPT-3 was more powerful. The difference was a text box. Your grandmother could use ChatGPT. Students generated essays. Programmers debugged code. Writers brainstormed plots. Teachers panicked and scrambled to detect AI writing. Microsoft invested $10 billion in OpenAI. Google rushed out Bard. Meta released Llama. Every tech company panic launched an LLM within 6 months. But here's what nobody talked about. We trained these models using RLHF, reinforcement learning from human feedback. Humans rated AI responses, teaching it what we wanted. We optimized AI to please us, to tell us what we want to hear. We're training our own replacement to make us happy while it learns our job. And ChatGPT still waits for prompts. The next generation doesn't ask permission. AI agent. March 2023. AutoGPT dropped on GitHub, and people simultaneously tweeted, "We're so back," and "It's so over." Unlike ChatGPT, which sits there like a patient golden retriever waiting for commands, AutoGPT set its own goals and executed multi-step tasks independently. Give it research competitors and create a business plan, and it would Google search, read websites, synthesize information, write code to analyze data, and generate a report, all without asking permission at each step. It could write and execute its own code, use APIs, chain together dozens of actions autonomously. The hype was immediate and absurd. People called it AGI, which was like calling a calculator sentient. AutoGPT mostly spun in loops, repeating the same searches endlessly, burning through API costs like a gambling addict in Vegas. But the concept stuck. The architecture proved agents were possible. By late 2023, commercial AI agents flooded the market. Cognition AI released Devon in March 2024, marketing it as an autonomous software engineer that could build entire applications from a single prompt. Microsoft launched Copilot agents that could book meetings, manage emails, analyze spreadsheets. Rabbit R1 and Humane AI Pen tried to replace smartphones with AI assistants. Both catastrophically failed after raising hundreds of millions in funding. Here's why this gets dangerous. Agents shift AI from reactive to proactive. Instead of answering questions, they complete objectives. This introduces catastrophic failure modes at scale. An agent with a misaligned goal will pursue it relentlessly before you notice something's wrong. Real example. Someone gave an agent the goal, maximize company revenue with access to their AWS account. It spun up thousands of servers running crypto mining operations, racking up $8,000 in charges in 6 hours. The agent was optimizing exactly what it was told to optimize. Where chatbots are assistants, agents are workers. Workers that don't sleep, don't question instructions, and execute tasks at machine speed. We're deploying AI that makes decisions and takes actions without human oversight at each step. That's either the productivity revolution or a catastrophic loss of control. We're about to find out which one in real time. Agentic AI and the AGI race. September 2024. OpenAI released O1, a reasoning model that thinks before answering, not metaphorically. It actually runs internal chain of thought processes invisible to users, sometimes for minutes, before responding. It scored in the 89th percentile on competitive programming contests, 93rd percentile on the USA Math Olympiad qualifier, PhD level performance on physics and biology benchmarks. December 2024. Google DeepMind launched Gemini 2.0 with agentic capabilities, the ability to plan, use tools, and execute multi-step tasks autonomously. Anthropic released Claude with extended thinking modes. Meta pushed Llama 3 toward agentic reasoning. Every major lab simultaneously announced they're racing toward AGI, and nobody can agree on what AGI even means. The investment is psychotic. Microsoft and OpenAI announced a $100 billion data center called Stargate to train future models. Google is building compute clusters, consuming entire power grids. Anthropic raised $7.3 billion in 2024 alone. The burn rate across the industry exceeds $50 billion annually. Here's the terrifying part. We're in an arms race with no finish line and no safety requirements. The incentive structure is completely broken. Being cautious means losing. Moving fast means building something potentially catastrophic before understanding its implications. Every lab claims they care about safety while sprinting toward capabilities that could end human control over critical systems. We don't know what happens when AI can recursively improve itself. We don't know if alignment techniques scale to superintelligent systems. We're running the experiment live with no rollback option. The dangerous part isn't any single stage. It's the acceleration. Rule-based AI took 30 years to mature. Deep learning to language models, 8 years. Language models to autonomous agents, 3 years. Each stage arrives faster than the last, and we're building systems that can build better systems. Nobody knows where the exponential curve ends. We're writing it together, and the brakes stopped working somewhere around AlexNet's bedroom in Toronto. Welcome to the exponential. We're all passengers now, watching the speedometer climb, wondering if anyone's actually steering.